In this section, we are doing hypothesis testing for two means from independent samples, and the sigmas are unknown. And just like in the previous sections, when working with the mean and sigma is unknown, we are going to be using the t-distribution. And the steps are very similar to the previous sections. Now we have two formulas, and they're both kind of complicated. So if the two population variances are not equal, then the information from the two samples is not pooled, and we would use this formula. But if the two population variances are equal, then the information from the two samples is pooled, and we would use this formula. And again, the rest of the steps are pretty similar to the previous sections. So here's the table of critical values. Number 1 says, the results of a standardized math test for random samples of students taught by two different professors at the same university are shown in the table below. The populations are normally distributed, and the population variances are not equal. At alpha equal to 0.10, can you support the claim that there is a difference in the mean test score for the students of the two professors? Use the rejection region method and show all work. Now the sample sizes are not greater than or equal to 30, but the populations are normally distributed. So yes. The claim is that mu1 is not equal to mu2. So this will be the alternative hypothesis. And the test is going to be two-tailed. The null hypothesis is that mu1 is equal to mu2. Alpha is 0.10. X bar 1 is 473. S1 is 39.7. N1 is 8. X bar 2 is 459. S2 is 24.5. And N2 is 18. Now it says that the population variances are not equal, so the data is not pooled. So our formula looks like this. So I'm going to type that into the calculator, and it looks like this. And it's equal to 0.922. For the degrees of freedom, we have to subtract 1 from each of the sample sizes, and then select the lower value. So the critical value is plus and minus 1.895. So our picture would look like this, and t is not in the rejection region, so we fail to reject the null hypothesis. And the conclusion would be, at the 0.10 level of significance, there is not enough evidence to support the claim that there is a difference in the mean test score for the two professors.